Thanks for coming. Good afternoon, and very happy Tuesday. Welcome to the session. As the title suggests, we'll be talking about AI solution that has been built to help the finance analysts in their day-to-day tasks. So let me kick off the session by introducing myself. My name is Umesh Jain. I lead the data and analytics for various customers in North America from Cognizant. I've worked in life sciences, retail, consumer goods, across various industries, spent a little bit more than 2 decades doing transformative programs for AI and analytics, data governance, so on and so forth. With me and my team, we implemented this solution for a life science customer, and then we took it to a retail customer. So I want to just draw attention that I don't know how many of you are from finance industry per se, but it's not a financial solution. It's a solution that could be taken up to a finance function or a corporate function in your organization. So me and my team have been through this journey from ideation to prototyping and implementing an MVP solution. So here's a quick preview of how we'll go through the next hour, the use cases which prompted this solution for us to get implemented. It is primarily in the financial governance and taxation area. We will then talk about also the proposed solution, the approach that we took, some of the principles. Given a GenAI solution, we had some key design principles that were to be followed. We will also talk about the various architecture components that we used to build the solution. And all of this for an outcome. We have a demo. Depending on time, we'll probably play the demo. But the purpose to help the finance analysts. So we'll look at the benefits derived. And like any other project, there are challenges. So we'll go through the challenges that we faced, the lessons that we had, so that as you go forward and apply this or a similar project, you should be able to take the learnings back from here. And while we implemented few of these use cases, we realized that there is a larger potential. So we will talk about the future use cases that we have in our thinking, and we are working with the customers to expand this. And this is a post-lunch discussion, so I can presume a lot of active listening. Again, if there are any questions, happy to take at the end as well. Open to hear any opinions, suggestions as well. What happens in Vegas does not have to stay in Vegas, so we all can take, I too get to learn something from here. I know I shared the agenda, but before going to the agenda, I wanted to give a broad perspective of the 3 dimensions that we are seeing GenAI use cases getting applied. The first is the business processes, which is an example that we will talk today. For example, in the financial domain, we are implementing this use case, where we are looking at business processes enabled. And being a life science, again, I deal with a lot of life science customers. I've put down a value chain of how in the business process, GenAI solutions could be applied across the value chain, be it drug discovery or be it manufacturing, supply chain, or to the commercialization. And what we will talk about is probably falls in this category. The other place that we also definitely see a lot of GenAI application is in the IT operations side. The business process we talked about are all dependent on the softwares and the applications which have to be up and running. Somebody needs to keep the light on. There is observability solutions. There is ServiceNow applications. They all are probably enabled today with GenAI. So that's why IT operations is one where we see a lot of GenAI use cases getting applied. The third is the actual development process itself, the software development lifecycle taking advantage of GenAI. So why I wanted to, again, there are code companions. It could be in data validation. It could be even to code deployments and so on and so forth. I'm sure you've been into various sessions today talking about all the technology advancement to help GitHub Copilot for that matter. So all I'm trying to say is this is the third dimension, and we could have GenAI infused in across all of this. With that, let me jump into the use cases that were a starting point. Two broad aspects of how we faced a situation where we realized that finance analysts had to spend a lot of time. In one place, it was about the various governance queries, about the accountings within the organization. And then there was also different queries the finance analysts had to kind of clarify around tax legislation. So that was one scenario where we started this. The second one was also more on an automation opportunity where the analysts had to spend a lot of time doing manual mapping of coding, what we call it as UNSPSC coding. I do not know how many of you are familiar with the finance. How many of you here are from, the finance? Okay, got a couple. All right. So again, if you are from finance industry, I'm sure you will know this. But if you are not, even if you are a finance function within your corporation, you should be able to kind of, relate. This helps the taxation that needs to be getting applied based on the code. It's hardly a few hundred codes, but there are thousands of products that get manufactured. This led to us realizing that we could have some AI intervention. What John McCarthy, how many of you have heard of John McCarthy here? Okay, I've got something for you. You'll have a takeaway. All right, so he's the one who coined the term AI. There is need for intelligence to be replaced from what is being done by humans. So here's the first use case which I talked about, the governance queries. This process required them to refer a lot of internal documents. And these documents could be as related to different country, region, topics, different subtopics. Topics could be as around accounting procedures, financial reporting, even general business procedures, and so on and so forth. And it's not a few documents, it's hundreds of documents out there. And these analysts are experts. I'm sure they know their trade well. But it's just the vast amount of content and updates to these policies that keep happening. It is very difficult for them to keep up. And not just the internal documents, they also have to certain times even refer external documents as well to be able to meaningfully or answer to the question that they have at any point in time from their finance team, because they are trying to kind of respond to an end user question. That's where we see an AI intervention here. We had a GenAI solution, a two-step exercise of identifying the right document based on the question, being identified to be able to respond to the question, and then also refer some external documents and bring relevant content, and not stop there. Also, a summarization of this response with meaningful explanation about it. That is how we went and implemented this AI solution for this use case of the first governance queries, which is all about the accounting procedures, financial reporting, and so on and so forth. The next one is around the tax legislation. This is very difficult when it's, digitization of the economy is causing a lot of tax challenges here. And we have, I don't know how many of you have heard of OECD here? Another question? No? Okay, all right, nobody gets nothing. It's Organization for Economic Cooperation and Development, who release some of the regulations that have to be kind of followed to be able to apply the complex rules. And at times, it even requires for you to be able to get new additional data to answer those questions. And it's just not these documents. They recently released what we call it as a Pillar 2. Those Pillar 2 documents come along with their own commentary documents, guidance documents as well. The Pillar 2 was released in 2021, and there are updated versions in 2022 and 2023. So you can imagine, again, the same challenge of finance analysts to be able to keep up, but it is probably a different realm of support that they need to provide. So both of these required a very similar scenario of being able to process a lot of documents and get to the right answer that was required to be providing guidance. A very high-level picture of depicting how we implemented this solution. As you can see, the analysts were responsible to answering the queries. But as I mentioned, it is a GenAI solution. So what we implemented, I'm sure many of you are familiar here with a RAG architecture, a retrieval augmented generation. But the core to that is the pre-processing engine that we created here. And we hear a lot of times, talking about chatbots, knowledge assistants created. But at the core is not just the GenAI solution. This pre-processing engine is very important when you implement such solutions. And we'll talk a little bit more about this pre-processing engine as well. That pre-processing engine brings all of the data that is available from these documents in a very curated way and helps provide the right context to the GenAI along with the end-user query, which is then responded back. And obviously, it also refers to the external documents. And throughout the solution, we had audit enabled, logging all the input and output of the data. And it is for a reason not just for auditing, but also improving the solution as well. This is the next use case that I earlier mentioned. This was not so much of a core GenAI enabled. Obviously, we use GenAI. We will talk about how, where. But the core here is we use an AI solution, which was then validated by GenAI. But the idea is, again, have the similar pre-processing engine, but these codes have to be mapped. And what we all input available is the description. That's it. And sometimes we even have only a handful of few words of descriptions. So we built an automation engine here, which would be fed in by all of the different content which requires or which helps the mapping. But then we also extended the solution by incorporating all the previous historical mappings that could be referenced as well. All of that fed into the AI engine and being able to then map and identify the right UNSPSC code. And it is a humongous effort because at times there are hundreds and thousands of these that have to be coded, which is currently happening manually. And we just didn't do the mapping. We also, let me quickly go to the next. Is a quick depiction of how this solution was implemented. Again, a very similar architecture, but not really so much of end-user query because we knew the effort here is more of mapping of the content or the input that's available from these descriptions that were available. And the output was, again, available to the analyst for a review. And I will talk about this review because what we created was a mapping, but at times we saw that the results were not accurate. So we definitely also had a human-in-loop mechanism to validate that. And how does the analyst validate? Again, they cannot be going through the hundreds and thousands again, right? So what we incorporated was a confidence score that was available to them. That confidence score was made through the combination of different search code, semantic search, as well as some lexical search as well. Through this, we could have finance analysts focus on some of those where we realized that there were gaps to be able to do some corrections. With this, I debriefed back a little bit background of the use case itself, right? The entire, how the different scenarios of, and this is the day-to-day work. And there are various such business use cases that you can probably imagine, not necessarily as a finance function. Any of your corporate functions in your organization should be able to implement something like this where the associates or the team, the core team, have to kind of go through that kind of material to be able to answer questions or do some automation. So here we talk about the implementation that we went through, the principles and the architecture. So being a GenAI solution, we wanted to ensure the solution was following the 6S framework, if I were to say. GenAI is not a magical solution. It is a powerful tool. And with power, there's responsibility. I'm sure everybody knows that. Where does that come from? Where does that come from? All right. I'm not able to see, but there's another prize out there. Anyway. So Security was, there are security threats that would be applied, that would be out here. We resolve this, and these could be security threats using prompt attacks from an LLM standpoint, and also disclosure of unrelevant data, any PII information that has to be secured. So we had constructs to be able to address them. Scalable design was the other one, build and use more. And a lot of times we see that for an initial prototyping purposes, it's OK to embed the code as integration of LLM into your solution. But as you expand, you need to build the AI solution, which then interfaces or interacts with your rest of the infrastructure and the software or the application. So this would be comprising of the prompts, the prompt orchestration, or even any of your data pre-processing as well, or for example, citations. So we'll talk a little bit about the different AI modules that we put in place so that it could be expanded as we built more use cases. Stability is another principle that we ensured to have the response consistent and grounded. We not only had validation framework at the end, but right from the beginning, from the pre-processing engine creation, we had the right mechanism. For example, I'm not sure how many of you are familiar with the chunking of the data, the embedding of the data. There are certain different techniques that have to be followed. So you got to ensure that the right techniques, depending on the content, is put in place so you get consistent and reliable responses. Similarly, when you're summarizing the response back to the analyst, it is important because, as you know, it could give some irrelevant context to it. So all of that is important. A simpler solution was also another important piece. When I say simpler, it's not about the UI or the UX here. The simplicity is all about ensuring that there is traceability to the source of information. For example, the response is there, but how did the AI solution give that response? The links to the source documents, and not only just the links, but also some explanation. And we will talk a little bit also about when we share the solution that we had some chain of thoughts to be able to explain why the AI solution thought that this was the right answer. The next one is to make socially aware, make the AI responsible. There are various different challenges when it comes to an AI solution. You got to have factors in terms of neutrality for gender, location. Even at times, there is harmful content. You got to also apply different content filters, and there's different ways of doing those filterings as well. There could be word filter that you would apply, but there's more advanced ways of you even providing a preset data set. Last but not least is the surveillance, which again, surveillance is purely from a monitoring standpoint to ensure that there's no hallucination. Similarly, there is a human-in-loop feedback, which is all tracked for anything to be able to be available for a future reference from an audit, as well as tuning or improving the solution. Here's a quick preview of the architecture. As you could see, we broadly had few of these layers, if I were to call them. The first, which is about the pre-processing engine. And if you recall, I earlier mentioned about the pre-processing engine. So we leveraged OpenSearch, the Amazon OpenSearch out here, where all of the different documents were embedded for a cognitive search to be able to provide a context as we implemented the RAG architecture. And this is the heart, because it is not just the embeddings. You cannot simply take the documents and put it out there for your cognitive search to work. We, in fact, had to kind of tailor between the two different use cases of how the chunking were done. There are different mechanisms of how you can apply them. And we used Amazon Titan for the same from an embedding generation standpoint. That's then available for the core layer, where we have an end user interface, the application, which allows the interactions with the end user to be able to bring the user query, tap into the LLM to be able to provide the context, then summarize the response, and be able to respond back. And it is not just the internal documents. If you recall, I earlier mentioned that there's external documents also available. So we built some APIs that could source and have additional context as required. And this is where an implementation of this architecture required a lot of design principles. Earlier I mentioned about the chain of thoughts as well, right? To be able to determine, hey, if external search is even required or not to answer any question or not. And not specific from an AI or Gen AI, we definitely had security controls, access, validation, and so on and so forth for the application. And this is about the method to the madness, right? It's not just putting to the architecture together. The first and foremost step is to understand the data, and which is what I was earlier referring to. If you do not understand your data, it is very difficult for you to build that pre-processing engine. Identify the key input. You have to build that custom engine. Identify the right technique. Go through that in an iterative process. And while I've laid down is a time frame, it's a 6 to 8 weeks or 12 weeks exercise when we are talking about doing all of this. But the idea is it does have to happen iteratively. So we build those prototypes, and at first, once we have realized that through this process now the cognitive search is functioning good enough, we start the whole prompt engineering exercise. Again, very specific to how the summarization has to happen in the response. Once we are fairly stable with the solution, we bring a human-in-loop process by applying validations from subject matter experts. And this is required because, as you know, we realized that there were a lot of times the response were not consistent. So that periodic validation helped us to be able to curate the solution better. And once we had a stable solution, we didn't stop there. Then we extended in terms of applying the right guardrails. Guardrails is purely to ensure, and again, we will talk a little bit more about what the guardrails are and how we applied them, but to avoid the hallucination, to ensure the responsible AI principles are applied. And we also had some evaluation framework put in place to ensure whatever responses are there are validated. So we had some metrics framework as well. So we had a validation framework, which would validate the result, and then an evaluation framework which probably will periodically throw some metrics. Here's the core, which I was earlier referring to, the AI solution, and scalable, build once and reuse, right? And breaking these into different components, we had different functions to be able to, and now this can be extended as a capability to any of the further use cases that we are expanding upon. On the front-end side, now we have a very robust set of modules which help with all of these functions. If the topic can change topic, it could now be extended to any other non-finance domain. The idea is to be able to have such a feature or a capability. Similarly, have the hallucination checks or the citation management. And obviously, on the back end, there were some core services that were created, be it the retrieval or the output valuation as well. And for example, the prompt injection, we now have a standard set of way to how identify prompt injection. So that's how we kind of ensured that the solution was robust. And we have some best practices. Again, I did not want to overwhelm with the solution itself. We will talk about the best practices upon, depending if the time permits. We have a demo too. I will park the demo probably for the later part, or if you want, I can go any suggestions, or if it's a 5 minutes demo, you could look at this video. You would like to? So this is the tax coder implementation that we did.
Today, I'm going to demonstrate a LLM-based text classification system that has been built by Cognizant team. Here, the use case is about predicting the correct tax code for a product with some given product information. And what are those product information? Right now, it is the product description, the department, the category, and the subcategory it belongs to. Our aim is to create a solution that can help businesses to correctly classify their products for tax computation. Now, what you are seeing here on the screen is an web-based UI. It is a very basic and primitive UI which we have basically built for the demonstration. So the code is running on my device and it has created a server, and as you can see it's running on localhost. So with this localhost we are accessing the web UI and we will predict the products or predict the product classes. Please note that product class and tax code can be used interchangeably down the line. So let's see how we prepare the product info. Now here we have some sample test products. So as you can see, it's the product description and we have product department, the category and subcategory it belongs to. Now this is the two product classes, but we are not bothered about the product class at this moment. We will generate these same product classes through the model and validate whether they are correct or incorrect. Now the column you see here is basically a concatenated form of this product description, department, category and subcategory, where each of these four fields have been separated by a comma. Now after each concatenated product information, we are also adding a hash. So this hash tells the model that this is the end of a product info and the next is product info for another product, so that the model identifies each product separately and predict corresponding classes. Now let us demonstrate with the first product. So here I copied the product info, and what we have to do is to paste it here on this window and then hit this submit button, and the corresponding class will appear on this window. So as we are predicting only one product, let us remove the hash. Now as you can see, it's taking some time. So right now we are using CSV or Excels to store the training data. Once it is employed with relational databases, the performance will improve further significantly. But as of now, we are focused more on the accuracy. So as you can see here, the class has been predicted and it is TPP goods. And the number you see here, the fraction, it is basically the cosine similarity score. Now let us validate whether it predicted right or incorrect. It's TPP goods, the first product. Yes, it has predicted correct. Now let me demonstrate another scenario. So let us take this product, the fifth one, which has the true product class as over-the-counter drug sold without prescription. Now let us see if model can predict the same. Okay, as you can see here, it has predicted two classes. So it has found that two classes are almost equal contenders. So what it does, it shows both of them and asks for human verification. So once the human or the human supervisor picks the correct class, which is this rank 2, it can be fed to the model, which will be the part of its progressive learning. Now as you can see here, the rank 1 is incorrect, but the rank 2 is correct. So doing so prevents the businesses from misclassifying their products. Now the question arises, does it only take one product input at a time? No, we can predict multiple products at a time, but the more product you try to predict at one go, the more time it will take. So let us try that.
So I'll pause there. Again, there isn't much. The next step is purely ensuring or recognizing that all of those processes. And luckily, in this demo, when we shared, you had a lot of other fields which could help. But in the actual implementation, when we looked at the data, there wasn't much information at all. It was really hard. And that is where we introduced two things. One is the confidence score to be able to help validate to what degree the response was right. And then we also had some GenAI validation brought in to be able to ensure that based on the history as well as some of the context, does the answer look right? The third is the step which he mentioned about manual validation itself. So all of this, again, as I mentioned, for a purpose, help the analysts. We could see benefits across all of these different aspects. Cost savings was directly out there because there were identified scenarios where an incorrect response could lead to certain obligations. Similarly, on the tax code, if you do not code them right, then you will have challenges to a downstream application as well. Efficiency, this, as I earlier mentioned, it's a manual process for the analysts today. It used to take at times even days for them to get back to the right because they had to refer all of this, right? We could bring them down to hours now, which is directly again savings from cost as well. But it's about operational efficiency. Quality was something where, as I earlier kind of referring to, one of the principles that we had ensure consistent and stable. So we had a validation framework to improve the quality. We did not have 100%. I would be false if I were to say that we had 100% accuracy. We had gaps, but then we had confidence scores and then human-in-loop mechanism to validate. And last but not least, it's a regulated. Again, as I mentioned, this was done for a life science customer. Regulation was very important for them, and like for any other industry for that matter as well. So having that being compliant in response is also an important thing. The next few slides is going to be more about the best practices that we want you to follow if you are planning to implement these solutions. But before I go to those frameworks, both from a validation or evaluation, a quick sneak peek of few of the challenges that we had. Earlier also I mentioned, right, that the chunking of the documents was important. In one place we used a recursive mechanism for chunking, while for another one we could not, and we had to go with a semantic model, semantic way of doing that. Also, there was, earlier I mentioned about the different versions of the document. If you recall 2021, 2022, 2023, we didn't want finance analysts to be confused and understand which versions the documents or the response was coming from. So we had a mechanism for it to be able to understand and only keep track of the differences between those documents and not just embed all of the historical documents as well. So a slight variance of how you handle the solution. And as I mentioned, there is required for you to be able to provide the right context. At times, since the conversations went in multiple iterations, we had to ensure that every time a context was created and provided back to the LLM and keep it within limits of the use tokens that are available. And the UNSPSC code, I think I mentioned that using the historical mapping was key to this solution, because without which the knowledge articles or the document as provided by the company for the guidance of mapping or even the external documents were not good enough. So we had to use that historical. So at times when you implement solutions, it's not just about the available data. You sometimes have to look out for additional data to be able to provide the right results. The confidence score as well I talked about, and in this confidence score, we just didn't rely on the AI confidence score, the solution itself, but also did the GenAI validation of this, and then had the analyst review those where they had gaps. Through these lessons is what a summary of this slide. Broadly, if you look, The core is a document search and retrieval, where you need to ensure that you follow these policies, have the right context established for your LLM. You need to have, and there are available now, in fact, from Amazon, to be able to apply the contextual grounding, which you should be able to take advantage of. That's the core pre-processing engine part of it, where you need to kind of take care of these steps. But not just the pre-processing, but also from the querying and the responses side. You got to have the guardrails to be applied to be able to avoid any or mitigate any hallucinations. So you have a chain of thought for you to be able to have an explanation of why the model is giving that response. Alternate response setup, again, was very important because you can't just simply give an answer to the analyst and say, this is the answer. So we had a mechanism where, there are thumbs and thumbs down, which would help probably for the model to understand. And at times, the analyst would have to probably just say, regenerate. And it is not a deterministic solution here, right? So you will likely have variances, but the degree of variances is what you got to be, looking for. And that's the nature of any of the LLM-based solution. In the validation setup, I will have another complete detailed explanation of what are the different validations or how you go about implementing any of the validations. So again, this is not to go into the technicalities of the solution, help understand a broad perspective of how in your business process, this could be applying to any of your non-finance functions as well. So if you have a process where you're requiring all of the responses to be given, referring to a lot of documents, here's probably a solution that you can take forward from the architecture standpoint, but also apply all of these as a best practices as you move forward. So here's a guardrail that I was earlier talking about. So if you look at it, right, depending on, so retrieval trinity is nothing but you're ensuring all of the, retrieval context is rightly created, the grounding information is provided. But from validation, what we did was, or not we did, I mean, typically any of your solutions, you would probably have two aspects, right? One is whether it's good or bad. You will have that kind of response. So you have a AI validation to perform that, or at times where you expect the answer will not be a binary. There is percentages validation or probability validation that you will have to apply. And some of the examples that you can imagine. In the automation engine that we built, it was a pretty straightforward a confidence score that we helped with. And here's what broadly, as you move forward, applying this to your projects, evaluate whether you need end-to-end automated evaluation, and you'll be able to determine its feasibility by these characteristics of your business process. If it fits into different categories of classification or purely summarization, you should be able to implement a lot of automated validation. But if not, then you will have to evaluate a human in loop. But again, there also it varies, because at times you may have experts, and there are scenarios where you may not have experts, where you leverage another GenAI validation also in your solution. So these are the different issues, broadly categorized, and how you should be able to kind of determine some mitigation steps, and also not just the mitigation mechanism, but also how to go about implementing them. I'll pick some of them. For example, ethical concerns, right? Responsible AI is one of the very standard framework that we apply, and regardless of how you move forward with any of the GenAI solution, this is something which you have to implement. Response quality. Response quality is a validation that you need to perform at all the different layers, not just at the end outcome. Even before implementing a technical solution, we use some AI techniques to just tap into the data, understand if the data had right answers, to be able to even move forward, implementing even a cognitive search on top of it. So you got to have that at different layers. And citations for search output, right, which earlier I was referring. Anytime you create, if you do that, your solution is going to be seen as more reliable from an end user standpoint. Prompt Sensitivity, again, it is a place where we use a lot of prompt templates. This way, we are able to reuse the different prompts, and you don't leave it to developers to be able to create their own prompt. With that, let me quickly share a little bit about the future use cases that we are talking about, because again, these future use cases are more in that finance space or the finance domain itself. You could apply, or you could imagine this into your environment and imagine what other use cases could be applied. Financial reporting. So a different solution from this, I've implemented with one of the customers, a content authoring workbench, where we are able to generate documents based on a template. Broad template is good enough, and a templatized AI-driven content authoring workbench has been created by us, which is going for regulatory submissions. So if you're having financial reporting, in this case, it's financial reporting. If it is in a medical space, it could be about regulatory submissions and so on and so forth. But the idea is to be able to create these financial reports, even have visualizations, charts, all possible through AI solution here, which we are planning as a next step, at least in this customer, the place that we are talking about. Forecasting and business planning, this is an important one, because what we've also seen is not just being as a generative solution here. We've also been able to use this with being able to provide different alternatives in the business planning processes through a GenAI solution. So you feed in your current plan, and it should be able to come up and share, hey, what could be the recommended alternatives in your current business plan. Third one is my favorite. While it's across, it's not just finance. Anywhere and everywhere, there is fraud and anomaly detection that's you need to apply, and this requires, though, a good amount of clean data. If you do not have data, it is very difficult, at least in this, right? Because the earlier one, you can rely on the existing knowledge articles and so on and so forth. But here, you need to ensure that different transactions, for example, if you're having a reimbursement mechanism in your organization. So ensuring the right documents are available alone is not enough. All the different transactions have to be available for it to be able to identify the different patterns. Compliance, this also would apply to any of your industries, not necessarily financial, but these are some of the potential use cases that we are thinking that we would immediately expand upon. But the idea is to build a larger roadmap for the organization within their finance function. And again, as I said, right, it's not necessarily a financial industry solution, but it is a solution that gets applied to any of the corporate functions you should be able to take. Here's a broad roadmap, but the idea is, to be able to deliver the business value that you are seeing here, right? Being able to improve the productivity is key. Faster processing of the documents for regulatory submissions is one we are definitely being able to see as one of the solutions that we can take forward. With that, I'll open up for any questions, if there are any questions here. All right, thanks for coming and appreciate your time.